Hello and welcome to Algebra 1 with Miss Betsy. I'm glad that you're here with me today. We're continuing our work where we're beginning to learn how to factor trinomials. We've talked about factoring the difference of two squares. We've talked about factoring perfect square trinomials. And today what we're going to work with is we're going to begin with some of the easier trinomials to factor, and that's where we have a leading coefficient of 1. But before we get started with that, I would like to know if you can tell me how in the world you would make 7 an even number. Okay, now, you know, of course, that 7 is an odd number, isn't it? 7 is an odd number, but if you take away the s, it's all of a sudden even. So yes, you may throw rotten tomatoes at me and everything, but that's how you make 7 an even number. You get rid of the s. So, moving right along with our lecture for today, I'm using as my text Algebra 1 for Christian Schools, and it's published by Bob Jones University Press. I'm using the second edition, and I am in Chapter 9, Section 4, where we are factoring trinomials of the form ax squared plus bx plus c. And I just said ax squared, and I bet it's not. It's not, because what I told you to begin with was where I said the leading coefficient is 1. Now you remember that the coefficient is the number that appears right in front of the variable. So this pattern here says we're going to be learning how to factor something that looks like this. Our first term of our trinomial is simply the squared term. The second term will have a coefficient in front of it. The third term is simply a constant term. Okay? And this is what we're going to be learning to factor today. You already learned how to recognize and factor the difference of two squares, and you learned how to recognize and factor a perfect square trinomial. And those are cool when they happen and they're very easy to do. You say, oh cool, I so understand this. I know how to factor 25x to the fourth minus 16y squared because I recognize that this first term here is actually 5x squared, and this second term is 4y squared. So I can use my handy-dandy cool little formula that tells me that when I factor the difference of two squares, the signs in the middle are opposite. The first term is the square root. First term in the factor is the square root of the first term. Second term is the square root of the second term, 5x squared minus 4y. And you think, how in the world did you come up with those numbers? Well, let's check and see if that's really what we have. 5x squared times 5x squared is 25x to the fourth minus 20x squared y plus 20x squared y minus 16y squared. You see that the two center partial products, the O and the I, the outer terms and the inner terms, outer product and inner product, cancel each other out. And you do have 25x to the fourth minus 16y squared. And all you had to do in order to be able to factor this difference of two squares, you have a perfect square here, a perfect square here, and we're subtracting. That's why they call it the difference of two squares. What you had to do was recognize that, have the pattern memorized, and you had your answer. It's a little bit different though, because we find that the vast majority of trinomials are neither the difference of two squares nor perfect square trinomials, and that you pretty much have to figure out how to factor those by a process of trial and error. Now it's an educated trial and error, and the more frequently you practice, the more of these problems you work, the easier it gets for you to be able to factor trinomials, but it takes a little bit of practice. So we're going to begin by using a very basic one, x squared plus 7x plus 12. Now the first thing that we're going to do when you have the instructions and it simply says factor, is you're going to look at this and you're going to say, okay, first, do I have any common monomial factors? Is there a factor that's common to all three of these terms? And there is not one. Check that off. Next, you're going to look and see, is this the difference of two squares? Well, obviously not. It's not the difference of anything, and it's a trinomial. Okay, now, is it a perfect square trinomial? In order for it to be a perfect square trinomial, first term squared, it is. The third term has to be a perfect square, which of course it's not. 3 squared is 9, 4 squared is 16. So now we say ick. Actually, you really don't say ick because they're fun, but you have to figure out how to do these. And I'm going to go ahead and refer to my book so that I'll stay right on track with what they want you to do. Now, ignore the fact that I just dropped the cap on the floor. When you are factoring a trinomial, first steps that you're going to want to take is you look at this first term here and you say, what in the world can I do to, what two factors can I break that up into so that I get x? Well, you can have x times x, or you could say 1 times x squared. Those are the only possible factors of x squared. Now, let's see what we can multiply together, what factors of 12 there are. Well, 12, you can say 1 times 12, you can say 2 times 6, and you can say 3 times 4. And we're not worried about the prime factorization here. We're just looking for pairs of factoring, because what we're doing is going sort of backwards so that we have two factors where we can use that FOIL method of multiplying together. Okay, so we have 1 times 12, 2 times 6, 3 times 4. We have a positive 12 right here. 1 times 12, 2 times 6, 3 times 4. What else could we do? Well, yes, you could say negative 1 times negative 12, negative 2 times negative, not a negative 3, negative 2 times a negative 6. You could also say negative 3 times a negative 4. Because when you multiply two negative numbers together, you get a positive. So we've got a positive 12 when we multiply together all of these three pairs of factors. Okay? Now let's remember how we got to this trinomial. And we did that by multiplying two binomial factors together. Remember, and we did FOIL, where we multiplied the first terms together, the outside terms, the inside terms, and the last terms. For those of you who are saying scratching your head, I'm going to go ahead actually and factor this one for us. What we learned a few sections ago was, oh, if I have two binomial factors, x plus 3 times x plus 4, how do I multiply that? Well, first you multiply the first two terms together. X times x is squared, is x squared. Now you multiply the outer two terms together. X times 4 is plus 4x. The inner terms get multiplied together. 3 times x is plus 3x. And finally, the last two terms get multiplied together. 3 times 4 is plus 12. You combine like terms and you have x squared plus 7x plus 12. This is what you learned to do just a little bit ago. Now what we're doing is going backwards. See, we have x squared plus 7x plus 12. So what did we remember from over here when we multiplied together two binomial factors? We remember that, I have ink all over my hands. We remember that we have two binomial factors when we have a positive sign in the middle and a positive sign with this last term here. The sign of both of these binomial factors is positive. And we also saw that we had to have a variable in both of these binomial factors, in both of these factors. So what does that tell us? That tells us that when we just have an x squared, we're not going to use 1 times x squared. We're going to put an x in both the first binomial factor and the second binomial factor. See, I'm being real careful to make that x, but I want to use a script x, just for consistency with how I write things. Now, remember we had FOIL. First, outside, inside, and last. The last terms, when we multiplied those together, that's how we got this 12, which is exactly why we had to multiply, we had to come up with factors of 12. We have 6 pairs of factors over here. Only 3 of these are going to be ones that we can use. Why is that? Because our signs are positive. So these negative factors here, -1 times -12, even though that gives us a positive 12, it doesn't work for this particular problem because these factors have to be positive. Now, this is the second part of, so we've got this trial and error going in here. 1 times 12, 2 times 6, 3 times 4. How are we going to know if we're going to do 1 times 12, or 2 times 6, or 3 times 4? When we FOILed this, x plus 3 times x plus 4, we had x squared plus 3x plus 4x plus 12. What did we have right here in the middle? We had the outer product, the inner product. We added those together. See, we have 2 factors here of 3 and 4. 3 times 4 is 12. What did we do with that inner product? We added them together. So what you are looking for in this problem is the 2 factors of 12 that when you add them together, you end up with 7. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. So it's that pair of factors, the 3 and the 4, that we're going to use to factor x squared plus 7x plus 12. Both of these are positive, so randomly pick which one of these. X plus 4 times x plus 3. This right here is the factored form of the trinomial x squared plus 7x plus 12. Okay, let's go ahead and do one where I don't show you how we FOILed to get to the original product. And you'll see that, yes, there is some trial and error involved here, but you pretty quickly figure out what's going on. Let me go ahead and use x squared plus 9x plus 8. We want to factor x squared plus 9x plus 8. Is this a perfect square trinomial? No, it's not, because 8 is not a perfect square. So we know that we're just simply going to have to factor this by trial and error. What do we have to do? both of these signs are positive, our factors are both going to have a plus symbol, no negatives. We simply have an x squared here, take its square root. We have to have a variable in the first factor and in the second factor. Now, what are we going to do? We have to look at this third constant term and we factor it. 8 is equal to 1 times 8. 2 times 4, negative 2, times negative 4, or negative 1, times a negative 8. These are the only possible factorizations of 8 that we have. We can already eliminate 2 of them. We're not going to use the negative factors because even though when you multiply them together, you get a positive 8, we don't have any place here where we're going to use negative numbers. Now what do? We only have 2 pairs of factors that are remaining. We have 1 times 8, and we have 2 times 4. How is it that we know which pair of factors that we're going to use? This is when we go right back to the problem and we say, aha, I have to find the pair of factors that when I add them together, I'm going to get a 9. 2 plus 4, is that 9? Nope. So, a little bit of misdrawing there. However, when you look at this first pair of factors, 1 plus 8, 1 plus 8 is equal to 9. So this first set of factors here is what you're looking for. While it's true that 2 times 4 is equal to 8, 2 plus 4 does not equal 9. So our factored form, x squared plus 9x plus 8, is x plus 1 times x plus 8. You'll pretty quickly realize that most of the time it's not going to be a 1 and 8. Here it is. But as you look at these, you think, okay, well, I'm going to have big numbers to come up with the 9. It's not going to be the 2 and the 4. So the more of these that you practice, the quicker you'll get with them. Now, let's go ahead and try another one. On page 376, we have x squared plus x minus 72. X squared plus x minus 72. We could also have x squared plus x plus 72. This problem is really, let me do one that'll work. X squared plus 3x plus 2. We could have x squared minus 3x plus 4. We have different ways that we're going to be dealing with the signs in our 2 factors. How are we going to end up with a negative number when you multiply 2 numbers together? One of those factors has to be positive. One of those factors has to be negative, doesn't it, in order to come up with a negative number here. How could we end up with a positive product? I said factor. In order to end up with a negative product of negative 72, we have to have one positive factor, one negative factor. In order to end up with a positive product here, we could have 2 positive factors. If we had a positive 2 and a negative 2, a positive 2 and a positive 1, add them together, you get your positive 3. Or, another way to get a positive number is with 2 negative factors. Negative 2 times negative 2 gives us a positive 4. negative 2 plus negative 2 gives us a negative 4. Okay? Minus 2. Minus 2. Okay? So your signs could be both positive, both negative, or positive and negative. So the examples that we're going to be doing now will deal with those different sign situations in the trinomial that we're factoring. So what do we have here? We have a negative third term, and that's going to tell us that our signs, one is going to be positive and one is going to be negative. We simply have an x squared in the beginning. The coefficient is 1. The only way that we're going to get x squared is to say x times x. Now, what do we need to do? We need to factor 72. So that when you multiply the two numbers together, you get a negative 72. When you add the two numbers together, you get a positive 1. So clearly it's not going to be 1 times 72. Clearly, it's not going to be 2 times 36. What about 3 times 24? No, because when you add these two numbers together, it's only going to be 1. It's not going to be 3 times 24 or negatives or positives. What about 4 times 1? 4 times 18? Yeah. 4 times 18. If you had like a negative 4, you'd still have positive 14. We only need a positive 1. So it's not going to be 4 times 18. Can you divide it by 5? No. What about 6? Yes. That can be 6 times 12. Well, it's getting closer, but we still only have to have a difference between those two factors of 1. That doesn't cut it. Cannot divide by 7. What about 8? Aha! 8 times 9 is 72. Okay? We have to have it equal a negative 72. The only way you get a negative product is if one of the factors is negative. So we have used our trial and error method to narrow down our factor choice to negative 8 times positive 9, positive 8 times negative 9. How are we going to tell which of these two pairs we use? The sign of our middle term is positive. So which of these, when we add the two factors together, do we get a positive 1? 8 plus a negative 9 is a negative 1. Negative 8 plus 9 is a positive 1. Whoops. Negative 8 plus 9. The factored form of x squared plus x minus 72 is x plus 9 times x minus 8. For this problem only, I'm going to go ahead and FOIL this out for you. X times x is x squared, x times negative 8 is negative 8x, 9 times x is plus 9x, 9 times the negative 8 is negative 72. You collect like terms and you see that, sure enough, when you multiply the two factors together, you ended up with your original problem. So you saw a rather lengthy example of trial and error until you find the exactly correct pair of factors that you need. So, which one am I going to do next? 2x squared plus 22x plus 48. 2x squared plus 22x plus 48. what's the very first thing that you always want to do? You always want to see if you have a common monomial factor. And every one of these terms is divisible by 2. So first you factor out the common factor, which is 2. That leaves you x squared plus 11x plus 24. Now to complete the factorization of this trinomial, just go ahead and factor this as normal. Both of the signs in the trinomial are positive. The center signs in those two binomial factors are positive as well. We simply have an x squared. So our first term in our factors is x, because x times x is x squared. Now, we're looking for factors of 24. Obviously, when you multiply them together, it has to equal 24. When you add them, it has to equal 11. Can't use negative numbers here, because though they multiply together to give us a positive number, when you add them, they give you a negative, and we need a positive. So we're looking for positive factors only, that when you add them together, those two factors together, you end up with 11. So obviously not 1 times 24, 2 times 12, 3 times 8, 3 times 8, when you add those two factors together, sure enough, you get your 11. X plus 3, x plus 8. This is our factored form of the trinomial, 2x squared plus 22x plus 48. Do not fail to include your common monomial factor. Don't forget, is horrid English. Don't forget the common factor. I think I'm trying to emphasize something there. It's very, very easy to drop that 2. Don't do it. Because if you simply have x plus 8 times x plus 3, you end up with x squared plus 11x plus 24. You have to multiply by that common monomial factor to end up with the original problem. Okay, let me do just one more for you. And this is a squared minus 5a minus 14. A squared minus 5a minus 14. There is no common monomial factor. We have a negative sign at the end. The only way you can get a negative product is if you have opposite signs. So we have a plus something, we have a minus something. We're looking for factors of 14 now, negative 14, that when you add them together, you get a negative 5. Well, you have 1 times 14 and you have 2 times 7. What are our choices? 2 times a negative 7, negative 2, times a positive 7. What happens when we add those together? Negative 2 plus 7 is a positive 7. I'm sorry, a positive 5. Not what we need. But if we add a 2 and a negative 7, we have negative 5. Therefore, these factors here, this pair of factors, is what we're looking for. And the factorization of a squared minus 5a minus 14 is a plus 2 times a minus 7. Block out enough time to work through these so that you can understand what's going on. The more you practice, the better you'll do. See you next time.